Welcome to the Ethiopian Construction Channel. We are glad to have you here. Our channel is dedicated to delivering professional, reliable, and high-quality construction content. We work with experienced professionals in the construction industry to share practical knowledge, modern techniques, and real project insights. Let us learn together. Today, we will see about classification of structure in building. In building construction, structures are commonly classified in a few clear ways, depending on how they carry loads, what they're made of, and how they're used. The first classification is based on load-resisting system. In this classification, we can see about load-bearing structures and framed structures. Load-bearing structures are buildings in which the walls carry the load of the floors and the roof. In this type of construction, columns are not used, or only a very few columns are provided. The walls themselves act as the main structural elements. The load from the roof and upper floors is transferred directly to the walls, then to the foundation, and finally to the ground. Because of this, the walls are usually thick and strong, especially at the lower levels of the building. Load-bearing structures are best suited for low-rise buildings, generally 1 to 3 stories high. For taller buildings, this system becomes uneconomical because wall thickness increases with height. These structures are commonly used in residential houses, particularly in rural areas, small towns, and traditional construction. Buildings made with brick masonry or stone masonry often follow the load-bearing system. Load-bearing construction is simple and economical for small buildings, but it offers less flexibility for future changes and expansion. Understanding load-bearing structures is important because they represent the traditional method of building construction and help us understand how modern framed structures evolved to meet the demands of taller and more complex buildings. Now let us understand framed structures, which are classified based on the load-resisting system of a building. A framed structure is a modern construction system in which the entire load of the building is carried by a framework of columns, beams, and slabs. In this system, columns are vertical members that transfer the loads safely to the foundation. Beams are horizontal members that carry the load from the slabs to the columns. Slabs form the floors and roofs and distribute the load to the beams. Unlike load-bearing structures, walls in framed structures do not carry any load. They act only as partition walls used to divide rooms and enclose spaces. Since walls are non-load-bearing, they can be thin, lightweight, and easily modified. This provides great flexibility in planning and interior design, allowing future changes without affecting structural safety. Framed structures are best suited for multi-story buildings, including high-rise buildings and skyscrapers. As building height increases, framed structures remain efficient and economical, unlike load-bearing structures. Most modern buildings such as apartments, offices, hospitals, malls, and towers are framed structures. The most common type is the RCC framed structure, while steel frames are used for very tall or industrial buildings. Now let us understand the load transfer system. The load acts on the slab, then moves to the beams, then to the columns, and finally reaches the foundation and soil. Because of this clear load path, framed structures are strong, stable, and safe when properly designed. They also perform better during earthquakes, as they can absorb and redistribute seismic forces. In summary, framed structures carry loads through columns, beams, and slabs, while walls act only as partitions. They are ideal for multi-story buildings and form the backbone of modern construction. The second is classification of structures based on material used. Now let us learn about the classification of structures based on the material used in building construction. The choice of material plays an important role in the strength, durability, cost, and purpose of a structure. Based on materials, structures are commonly classified into masonry structures, RCC structures, steel structures, timber structures, and composite structures. First, masonry structures. Masonry structures are constructed using brick masonry, stone masonry, or concrete block masonry. In this type of structure, the masonry units are joined together using mortar. Masonry structures have good compressive strength, which means they can safely resist loads acting vertically. However, they are weak in tension, so they are not suitable for structures subjected to heavy bending or earthquake forces. Masonry structures are commonly used in residential houses, compound walls, and low-rise buildings, especially in traditional construction. Next, RCC structures, also known as reinforced cement concrete structures. RCC structures are made by combining concrete and steel reinforcement. Concrete is strong in compression, while steel is strong in tension. Together, they form a strong and durable construction material. RCC structures are the most common type of modern construction used today. They are widely used in houses, apartments, offices, bridges, and public buildings. Because of their strength, durability, and flexibility in design, RCC structures are suitable for both low-rise and high-rise buildings. Now, steel structures. Steel structures are made mainly of structural steel sections such as beams, columns, and plates. Steel has very high strength compared to its weight, making it lightweight and efficient. Steel structures are commonly used in industrial buildings, factories, warehouses, bridges, and high-rise frames. They are especially suitable for long-span structures and buildings that require quick construction. However, steel structures require protection against corrosion and fire to ensure long-term safety. Next, timber structures. Timber structures are constructed using wood as the primary material. This is one of the oldest building materials used by humans. Timber structures are mostly used in small buildings, cottages, and traditional houses, especially in areas where wood is easily available. They are lightweight and easy to construct, but they are less durable compared to RCC and steel structures. Timber also requires protection from termites, moisture, and fire. Finally, composite structures. Composite structures are made using a combination of two or more materials, such as steel and concrete. In composite construction, each material is used where it performs best. For example, steel provides high tensile strength, while concrete provides compressive strength and fire resistance. Composite structures are commonly used in modern high-rise buildings, bridges, and large commercial structures. They offer high strength, efficiency, and economy. To summarize, classification based on material helps engineers choose the right structure for the right purpose. Masonry, RCC, steel, timber, and composite structures each have their own advantages and applications. Understanding these materials is essential for safe, economical, and efficient building construction. Classification of structures based on material used has advantages and disadvantages. Now let us learn about the classification of structures based on the material used in building construction. The choice of construction material plays a very important role in determining the strength, durability, cost, safety, and overall performance of a structure. Depending on the type of material used, structures are commonly classified into masonry structures, RCC structures, steel structures, timber structures, and composite structures. Each type has its own advantages as well as limitations. First, masonry structures. Masonry structures are constructed using bricks, stones, or concrete blocks bonded together with mortar. These structures have good compressive strength, meaning they can safely carry vertical loads. They are economical, easy to construct, and require less skilled labor. Masonry structures also provide good thermal insulation and have a long service life when properly maintained. However, masonry structures have some disadvantages. They are weak in tension and cannot resist heavy bending or earthquake forces. Because of this, they are not suitable for high-rise buildings or seismic zones. Masonry construction is mostly limited to low-rise buildings, residential houses, and compound walls. Next are CC structures, also known as reinforced cement concrete structures. Our CC structures are made by combining concrete and steel reinforcement. Concrete is strong in compression, while steel is strong in tension. This combination makes our CC structures very strong, durable, and versatile. One major advantage of our CC is that it can be molded into any shape, allowing flexibility in architectural design. Our CC structures also have good fire resistance and require less maintenance. However, our CC structures also have disadvantages. They require proper curing and skilled supervision during construction. The initial construction cost is higher compared to masonry structures. If not designed or constructed properly, cracks may develop over time. Despite these limitations, our CC is the most widely used construction material today for houses, apartments, bridges, and high-rise buildings. Now, steel structures. Steel structures are made using structural steel sections such as beams, columns, and plates. Steel has a very high strength-to-weight ratio, which makes the structure lightweight yet strong. Steel structures allow fast construction, large spans, and are ideal for industrial buildings, warehouses, bridges, and skyscrapers. They are also recyclable, making them environmentally friendly. On the downside, steel structures are prone to corrosion and require regular maintenance. They also lose strength at high temperatures, so fire protection is necessary. The cost of steel can be high, and skilled labor is required for fabrication and erection. Next, timber structures. Timber structures use wood as the main construction material. Timber is lightweight, easy to work with, and provides a natural aesthetic appearance. It is commonly used in small buildings, cottages, and traditional houses. Timber structures are also quick to construct and provide good insulation. However, timber has several disadvantages. It is less durable compared to our CC and steel. Timber is vulnerable to termites, moisture, and fire, and therefore requires proper treatment and maintenance. Because of these limitations, timber structures are not suitable for large or long-span buildings. Finally, composite structures. Composite structures are constructed using two or more materials, such as steel and concrete, to utilize the best properties of each. For example, steel provides tensile strength, while concrete provides compressive strength and fire resistance. Composite structures are highly efficient, economical, and strong, making them suitable for modern high-rise buildings and bridges. The main disadvantage of composite structures is that they require advanced design techniques and skilled construction methods, which may increase initial costs. However, in the long run, they provide excellent performance and durability. Conclusion. To conclude, classification of structures based on material helps engineers select the most suitable type of structure for a specific purpose. Each material masonry, RCC, steel, timber, and composite has its own advantages and disadvantages. Understanding these materials is essential for achieving safe, economical, and efficient building construction. Thank you for watching. We hope you found this video helpful and informative. If you enjoyed the content, like the video, share it with others. Subscribe to our channel for more professional construction content.